Hi everyone, I wanted to just explain a little bit of what we're learning. Matter can be three things. It can be a solid, a liquid, or a gas. So if you look at this is a solid. How I like to explain it to students is if I drop this, it's still going to be scissors. If I throw this or drop this, it's still going to keep its shape. When an object keeps its shape, it's a solid, and the atoms are the smallest type of matter, stay together. They're pretty close together like this. When I get a liquid, if I have a bucket, so if I, hold on one second. If I took this bucket and filled it with water, the water would change shape to be the shape of my bucket. Whereas if I had it in a water bottle, it would change the shape to be like a water bottle. When atoms are liquid, it means that they're moving around just a little bit, okay? Not a lot. The atoms are just moving around a little. When you get a gas, think of an air balloon, the little atoms inside are bouncing all over. So I wanted to show you this video really quickly and read it because it doesn't read. So all elements in our universe are composed of atoms. They're the smallest form of matter. So that's what we've been learning about. And then, so it's going to give an example. So these are our atoms, okay? So remember, an atom is the tiniest part of matter. And matter can be solid, liquid, or gas. So these are little atoms. They're moving around. The way an atom acts is directly affected by heat, and we've been learning about heat energy. So that's why it's important to understand about matter and how the atoms, the little tiny pieces of matter, are affected by this heat. So when heat is added, atoms move much faster. Oh, whoops, I didn't finish. Whoops. Third time. When heat is added, atoms move much faster and spread out from one another. So let's watch what happens to the atoms. Okay, so now they're moving around very quickly. They're bouncing about. On the other hand, when heat is taken away, atoms will move slowly and crowd together. So heat speeds it up. Cold slows it down. See how slow they're going? At high heat and low heat, atoms maintain some form of motion. That changes once temperatures reach absolute zero. Okay, so we don't need to go into the rest of that. I wanted to show you the next activity you'll do after watching this video in Nearpod. You're going to see something like this. This is called a simulator. That means it's not real, but it's a fun little thing for you to play with and learn things about. So right now, these are my atoms. You can see them bouncing around. Remember, atoms are my tiniest part of matter. Okay, so right now these little atoms are making a solid. See how they're organized? A solid. My scissors is a solid, and they're really close together and organized. Okay? When I make it a liquid, think of water. My atoms are kind of organized, but they're moving around like water does. Okay? They're not totally all there. And then when I change it to a gas, it's all over the place, right? Lots of space between them. So I wanted to show you this. You can do argon, oxygen, here's water. You can just do neon. None of those matter. So the thing that's kind of fun, let's go back to a solid, is you can heat it up or make it colder. So if I heat it up, look what happens. Did they go faster? And the faster they go, the more energy I'm creating. So heat energy is created as these little atoms are moving faster. And then, so here we go again. Now let's cool it down. See how they're not as fast? They're going slower and they're closer together. Okay, let's see a liquid. Heat up a liquid. Moving faster again. See that? Make it cold. Much slower. Okay, here's my last one. Much faster. Much slower. Okay, so I hope you have fun doing this little simulation and playing around with matter.